7.2, polynomial functions and their graphs. First thing we're going to do is we're going to graph p of x equals x cubed plus 3x squared minus x minus 3. The nice thing about this lesson, we don't graph these by hand. We're going to use the calculators. In the calculator, first thing I hit is y equals. You're going to get an error if you have this plot 1 turned on. If it's a black highlight over top, turn it off. We type in the function. X cubed plus 3x squared minus x minus 3. A lot of the mistakes are made because you type them into the calculator incorrectly. The cubed is in the math, number 3. Or you can just use caret 3. It's the same thing. You don't have to put this one. You can use the caret 3. Everyone hit zoom 6. That way we all have the exact same window. So when you graph it, it looks like this. Anyone not look like this? What can you tell me about this graph? Goes up, goes down, goes up. Sort of looks like a roller coaster, right? How does it start off? Goes up, and then it hits this point, and then goes down. What do you think we call this point here? It's a maximum, but it's not the overall maximum. This one here is called the local maximum. That's the local max point. What do you think we call this one? Local min. This graph does not have a minimum and it does not have a maximum because it goes on forever down this way and goes on forever up this way. So we're going to find our local max. How can I find out what this point is? Okay, we don't want to use trace because we want to know the exact points. Second, trace. I'm trying to find the maximum, so I hit 4. Now it's saying left bound. All right, I know the vertex is right about here, which is right about -2. So give me a number to the left of -2. -4. Give me one that's to the right of it. 0. Doesn't matter what we pick as long as it's in between these two. I press enter. My maximum is at -2.15, 3.08. All right, now finding the minimum value is just like finding the max. To find this point here, I hit second trace. But instead of the maximum, I want the minimum. So I press 3. Here's my minimum. Give me a point that looks to the left of it. -2. That's fine. Give me a number that's to the right of it. 2. Try not to pick a number that's right next to it. 0 is a little bit close. Try to give yourself a little bit of a window. I don't care what your guess is at. Enter. I have a minimum at 0.15, -3.08. Any questions on this so far? Find the local max, the local minimum. Just applying what we did in the past to now. So you already told me the graph goes up, goes down, then goes up, right? If it goes up, would we call it increasing or decreasing? So it's increasing from here to here, right? So it's increasing. When does it start to increase? Does it ever stop down here? No. What would that be as a number? If it never stops, what number do we use? Or what do we use? Infinity. But this is going down, so it's going to be negative infinity. Comma. Where does it stop on the x values? It's a sideways 8. It's infinity. Mine are always sloppy. When does it stop? Right here. What's the x value right here? Is this my max or my min? This is my max. What's my x value of my max? Negative 2.15. What happens from here to here? It decreases. Where does it decrease from? What 2 points? From negative 2.15 to 0.15. It goes from my max to my min. So it decreases from negative 2.15, and it stops at 0.15. What happens after that? It goes back up. So when does it start going back up? It starts going up again at 0.15. When does it stop going up? Does it ever stop going up? So what are we going to use? Infinity. That is my intervals of increase and decrease. This is the way you should be able to do a problem. This is continuous from here to here, correct? Start at negative infinity, it goes to here. I go to here to here. It's negative infinity because it starts all the way down here. It's positive infinity because it's going to keep going up and up and up forever. I can start and I should be able to trace negative infinity to negative 2.15, negative 2.15 to negative or to 0.15, 0.15 to infinity. You should be able to trace through from negative infinity to positive infinity without any gaps. You understand everything here? What numbers do I need the most? What is everything based off from? The max and min. And what values do you need out of the max and min? The x values. Any polynomial can be written in standard form as p of x equals a to the n, x to the nth, plus a to the sub n minus 1 to the, or times x to the n plus 1, all the way down to a plus 0. With that being said, the leading coefficient for a sub n of x to the n tells us the n behavior for any polynomial function. So I'm going to have a chart here. The number out front is either going to be positive or it's going to be negative. What number is missing from here? What number is not included in either of these? Zero is not included. What happens if a is 0? What happens if I have a is 0 here? What's 0 times anything? So what's really happening to it? It goes away. That's why it can't be equal to 0. It has to be a positive number or it has to be a negative number. On the previous problem, we're just looking at our original function. What is our a? Not 3. What's our leading variable? X to the third. What's the number, the coefficient attached to that? 1. So it's a 1. What category does it fall in? This one or this one? Left or right? Why left? 1 is greater than 0. Yeah, you need this chart. So how did our graph look? These dots, it's just everything in between. How does our graph start? What's happening here? Is it going up or going down? What happens on the left of it, of our graph? It's going up. And what does it do over here on the right? Okay. There's another little case here. If n is even, n is odd. So this goes up and it's going up here. What is my n in our previous problem? N is just the exponent of the first one. It was x cubed plus 3x squared minus x minus 3. My a is 1. My n is 3. Is n even or odd? N is odd. So it's going up, up. Let's go up here and make this leading one even. Give me an even number. I don't want to use, okay, I'll use 2. I'm just going to delete this part. My leading coefficient is what? 3. 3 is greater than 0, correct? So it's still in this column. When I graph, what happens to it from the left? Is it going up or down? Down. What's happening on the right? So if it's even, it's going to go down and up. Just to show you. Give me another even number. 4. I changed from x squared to an x to the 4th. Okay, it's harder to see. Let me see. It goes down, it goes up, right? I'm going to change this to a 6. 6. What happens? Still going down, still going up. I'll use an odd number. Give me an odd number. 5. What's happening to it? Going up and then going up again. Every single problem, if you just look at that first term, now it has to be in order. It has to be in standard form. Just by looking at this one here, you could automatically know, is it going up, up, down, down, down? You're going to see the different ways. Now it's less than 0. So the first one is even. So give me an even number. 2. Okay, give me a negative number. -1. So just put a negative out front. What happens to my graph? It's going up, then down. Up, then down. So horrible down. Let's see, we'll change this to a -2. Give me another even number. 6. What's happening to it? Up and down. Regardless of what it is, you have a negative out front, and that exponent is even. It goes up, down. What do you think the last one's going to be? Down, down? Let's see. N is odd. Give me a number that's odd. 5. Graph. Goes down, down. You have to know this chart. I can put in any other number. I'll put in a 7. The graph is still going down, down. This works for any graph. Do you understand what we did here? Do you understand what we did here? It's all calculator work. There's no work to do by hand, but you have to know how to manipulate the calculator. You know how to have to find the max and the min. What's that? A is always in front of the leading coefficient if it is written in standard form. If it's out of order, you got to look to which one should be the leading one.